Hi, my name is Raul, and I'm a developer on the Conduit team. In a previous video, I showed you how I configured a Conduit pipeline to process PDFs coming from S3 automatically and creating chunks for each one of them. Chunking is a crucial step when it comes to processing information such as large documents. This ensures the embeddings I later need for my LLM are connected to a reasonable context. In this video, I'll continue with the next steps for building a complex RAG knowledge system with Conduit. Make sure you check out the first video of this series to understand the desired end solution. Today, we'll continue adding processors to our pipeline so that the data continues evolving even before it reaches the destination connector. This is how the data looked in my previous video. In the payload after field, we already had a chunks key that contains all the different pieces of my original PDFs sent by S3. Since what we ultimately want is to have an LLM be able to access my information efficiently, we'll need to associate these chunks with the appropriate embeddings generated by my LLM. For this, I'm going to run an OLlama server on my machine using this model to create the embeddings. There are different ways to install OLlama on your machine. In my case, I used Homebrew. Once you install it, you need to go ahead and install a couple of models. Here's how you can check if you successfully install them. To interact with OLlama from Conduit, you need to make sure you have it running. By default, OLlama runs on port 11.43.4, so you can check if it's running by visiting localhost on that port. This is the address I will use to connect to it. I'll go ahead and start adding this environment variable that I'll later use in my pipeline. Now it's time to add some processors to my Conduit pipeline. If you remember, the last processor I had left my record with the payload after field and the chunks key. For each chunk, I need to create the embeddings and connect the two. I'm going to make a post request to the OLlama server to create embeddings using this request and sending this body. I will add a response to this request to payload after embeddings. The response for these embeddings will be in raw data format, so I will need to decode embeddings by using JSON decode. Let me run the Conduit pipeline and see what we have after this last processor. To clearly identify what we have, I will only upload one document to S3. Here we can see that while we have successfully created the embeddings for each chunk, these are not correlated with each record. I have chunks in one key and embeddings in another. What I need is to have the two connected so I can later use an LLM to ask questions about these blocks of text. For this, we could simply use a custom JavaScript processor and write my own function in line to connect the two. For this purpose, I'll create a new array named formatted and will iterate over the chunks to associate them with the created embeddings by my LLM. At that point, I'll call structured data to create a structured data object so I can easily set my newly formatted array to my payload. I'll set it to the new items array JSON field. You can read more about this custom JavaScript processor on the documentation page. Before I run Conduit again, I will clean up the content of the file so I can see only the record I'm about to process now. Alright, let's run Conduit again. Upload another PDF to my S3 source and wait for all processors to do what is expected. Head into the file connector to see what's produced. I should see a new items field as part of my payload at any moment. After that, I should have both chunks and embeddings connected. Let me format the file so we can see it better. And here we go. We can see now the end result of my processed data is exactly what I would expect, having both chunks and embeddings connected. My next and final step of this AI pipelines showcase will be to store this in a relational database so that my chatbot UI can answer all my questions using the latest documents automatically processed by Conduit in real time.